Welcome back to part 2 of repeated linear factors. Last time we left off, we'd solved uh, these equations, and our original set of equations was 1 equals to a plus c, 1 is equal to 3a plus b plus 2c, 1 is equal to 2a plus 2b plus c, which are labeled equations 1, 2, and 3 respectively. We then solved equation 1 for a. Then we substituted that into equation 2 and 3. Okay. Upon substituting it, we simplified these equations below to get equation 2 star, which is minus 2 is equal to b minus c, and equation 3 star, which says that minus 1 is equal to 2b minus c. We then take equation 2 and we solve for c. We get the equation c is equal to b plus 2, and we substitute that into equation 3. So let's do that now. So that gives us minus 1 is equal to 2b minus c, and c is b plus 2. So that says minus 1 is equal to 2b minus b, and instead of having a c above, that should have been a b plus 2. I believe I said that, but then wrote c. Then that'll be minus 2. Okay. We'll move the 2 to the other side. That will say 1 is equal to b. So one solution is b is equal to 1. So we now know one of the constants. Hey, c is equal to b plus 2. So 1 plus 2 is equal to c. That gives us 3. Okay. Then from equation 1, we have a is equal to 1 minus c. So we'll just write that out again. A is equal to 1 minus c. C is 3, so that's negative 2. Okay. So we've now determined all the coefficients for the partial fraction decomposition. If we go back up, we wrote out this partial fraction decomposition of x squared plus x plus 1 divided by the quantity x plus 1 quantity squared times x plus 2 is equal to a over x plus 1 plus b over x plus 1 squared, coming from the repeated part, plus c over x plus 2, the non-repeated part. Well, we've now determined a, b, and c, and let's plug that in. So I rewrote that down here. Here's a, b, and c. Let's rewrite that, and I'm going to erase a, b, and c and put the appropriate constants. Okay. So a is negative 2, so I'll put the negative part out in front, then there'll be the 2. B is 1, and c is 3. Okay. So if we want to integrate this quantity using the partial fraction identity, I can just integrate minus 2 over x plus 1 plus 1 over x plus 1 quantity squared plus 3 over x plus 2 dx. Okay, and that's what I have to integrate are those three terms. Now let's go back up. I think under the review we integrated one of those terms. Okay, that would be the integral of 1 over x plus 1 squared. Under review item 2a and b, I think we've integrated the other two terms that are required. So just putting that information together, the antiderivative of each of this will be minus 2 times the ln of absolute value of x plus 1. And, you know, the details are above in the review, minus 1 over x plus 1 plus 3 times this ln of absolute value of x plus 2, and then we add our constant. And that is the antiderivative of this item. And as you can see, the bulk of the work is not in the integrating part, but at arriving at the partial fraction decomposition. It's imperative to know the correct form, then to go through the algebra to solve for the constants. Thank you very much.